All right, how are we doing, everyone? Advent of Code, day 6, 2015. All right, we're going to get started. Made it partway up the tree now, so we're going to try number 6. All right, day 6, probably a fire hazard. Because your neighbors keep defeating you in the holiday house decorating contest year after year, you've decided to deploy 1 million lights in a 1,000 by 1,000 grid. Okay, so we have a grid. Furthermore, you have been especially nice this year. Santa has mailed you instructions on how to display the ideal lighting configuration. Lights in your grid are numbered from 0 to 999 in each direction. The lights are at each corner at 0, 0, okay, so typical corners. The instructions include whether to turn off, turn on, or toggle various inclusive ranges given as a coordinate pairs. Each coordinate pair represents the opposite corners of a rectangle inclusive. Okay, represents opposite corners of a rectangle inclusive. A coordinate pair like 0, 0 through 2, 2 therefore refers to 9 lights in a 3 by 3 square. Okay, so this is going to be the top left and this is going to be the bottom right. Or maybe top right, bottom left. Opposite corners. The lights all start turned off. To defeat your neighbors this year, all you have to do is set up your lights by doing the instructions Santa sent you in order. For example, turn on 0, 0 through 999 would turn on or leave on every light. Toggle 0, 0 through 999 would toggle the first and last line of 1,000 lights, turning off the ones that were on and turning on the ones that were off. Turn off, that 499 through 500, 500 would turn off or leave off the middle 4 lights. After following the instructions, how many lights are lit? Okay, so let's do, so I'm going to create a struct for a light. Struct. Maybe, no, it's a class because it's going to have on or off. Class light. And it's going to be var is on. It's going to be a Boolean. And yeah, is var is on Boolean. And it's going to have functions turn on is on equals true, func turn off is on equals false. Actually, let's start with well, we don't have to do a set on because we'll just set the ivar. Func toggle is on equals is on. Okay, so that'll take the current state of is on and toggle it. Actually, I think there's even a Boolean operator called toggle. So I might not even need the light struct, but I'm going to keep it anyway because we might find out that the next puzzle uses it. Okay, so what I'm going to do is I'm going to take, okay, so we start with a rect. So we'll start with a grid. Grid. So, I know. Class light board. So the light board is going to have a bunch of lights. It's going to be in a dictionary. So var lights, and it's going to be a dictionary by grid coordinate, and there's going to be a light at that coordinate. Okay, and do they start off? Okay, lights are numbered 0. Lights are, yeah. I have to assume they start off. Does it say? The lights all start turned off. Okay, good. So, we're going to do a init, and the way we init this is we're going to take a grid rect. We're going to create a grid rect that is the correct size. So origin left 0, left 0, top 0, width is 1000, and height is 1000. Okay, and then let rect. And then for each rect dot coordinates, yes. Okay, so this returns a set of coordinates of every single coordinate that exists within this rect, right? All right, let's drill in. Coordinates is a set of grid coordinates, yeah, for each x and for each y. So it's going to return 1 million coordinates, and I'm going to say dot for each, and I'm going to say coordinate and we're going to say lights coordinate equals light is on, let's do this, is on is false. So these all start turned off. Okay. So this should never return null, at least as long as I'm within the bounds of this light board. So then I'm also going to have a function that does a process rule or process. Okay, so we're going to have instruction. Okay, so we need to enumerate the instructions here. Okay, so we have a struct, or actually it's an enum, and we have instruction. And the instruction is going to have a command. It's going to have a verb, either turn on, toggle, or turn off. And the free verbs are going to be case instruct. No, it's, oh shoot, no, this is going to be a struct because all of them, right? Struct. Let's just look at the puzzle input real quick. Yeah, so they have the word through. Okay. So it's going to have a start coordinate. Var start coordinate is going to be a grid coordinate. And the var end coordinate is a grid coordinate. And then we have the var start coordinate, end coordinate, and then we'll also probably have a computed var for rect. And that's going to be a CG rect. Or no, I'm sorry, it's a grid rect. And that is going to be computed, and it's going to return a grid rect at the location start, origin, yeah, okay. Left is going to be start coordinate. Ooh, wait a second. Grid rect dot containing, enclosing. Ah, yes, look at this. Look, I feel so proud of myself. Okay, start coordinate, end coordinate. So what this will do is it'll create a rect that encloses these 2 points. So no matter what, whether it's the top left and bottom right or the top right and bottom left, either way, it'll enclose the entire rect. Which is what? Exactly, this is exactly what we want. Okay. So we have the start coordinate, end coordinate, and then we also have the var, we have a command, right? Var command. And that is going to be, oh, you need to create an enum first. And that is, the enum is going to be called command. And the command is going to be one of 3 things. It's either going to be turn on, toggle, or turn off. Case, turn on, case, toggle, turn off. Keep it nice and symmetrical, toggle. Okay. So each instruction, so I'll be able to take this light board and have a function that func process instruction. So when we get this instruction, what we're going to do is we're going to take the enclosing rect, func var, so let rect equals instruction dot rect, and then switch on the instruction dot command. Oh, I didn't get that far. Okay, var command is a command. Okay, we're going to switch on the command, and it's going to be, if it's a dot turn on, then we do, actually, let's start by saying let all lights affected lights equals rect dot coordinates dot map, and it's going to return lights. Okay, so this is going to be, this variable is going to be the coordinate that is passed in. So this is going to return an array, a set of lights, or maybe an array of lights. I don't actually know. Okay, do I need to build? What's going on here? Never used. Yeah. Okay. I just wanted to see what the type was. It should be like, it's a collection of lights. Okay, so turn on affected lights dot for each dot slash dot turn on. Case dot turn off affected lights dot for each turn off. Case dot toggle affected lights dot for each dot toggle. Okay. There's only 3 different commands, so that should be exhaustive. Yes, it is. Oh, I see, because I did not do lights. Lights equals an empty set. Okay, build succeeded. Okay, so now the next thing I need to do is I need to initialize this based on a line. So init descriptor, let's do descriptor, and that is going to be a string. And then this is going to be parsing the string. So for instance, this turn on 00 through 999. What that means is I'm going to have to, so first I'm going to have to get the first, ooh, geez, okay. How am I going to do this? I'm going to have to do like a regular expression type deal. So I think I should have some, in my toolbox, I should have a regular expression parser. Yeah, regex parse string, regex, and it's going to have a function, it's going to have an array. So the array returns, I wish I had comments because I wrote this over a year ago. Range, ns range, okay, remove first, ns string. Okay, so then it's going to map the, okay, this should be exactly what I want. So let components equals regex parse, and the regular expression is going to be, so, ooh, I need to open a new browser window. I'm going to open this. I'm going to say debugx. This is what I like to use. So the first component is going to be one of three strings. It's going to be either, how do I do an uncaptured group? I think it's like that. Or no, it's like maybe a question mark at the beginning. That sounds right. And this is going to be turn on or uncaptured group, question mark, colon, turn off. Okay, where's my cheat sheet? Just show the cheat sheet by default, please. A or B. Oh, a positive look ahead, non-capturing. Okay, so the parentheses is on the inside. Got it. Okay, turn on, turn off, or toggle. Okay, and then there's going to be a space, and then there's going to be a coordinate. So that's going to be we're going to go like this, and it's going to be a number. \n. No, it's a new line. What's a digit? Oh, it's a D. \d. \d plus. So that's going to be one or more Ds. Okay. And comma. And then one or more Ds again. Okay. And then there's going to be a space. So we have turn on, turn off, toggle. And then we have X1, Y1 through. And we have another one. This is going to be X2, YB plus, comma, \d plus. Okay, that should do it, right? So we have group 1 is the instruction, group 2 is X1, group 3 is Y1, the word through, X2, Y2. Okay, so this is going to be my regular expression, just like that. And I'm going to process the descriptor. Now, I believe this should return an array of components in this order. So the first item will be turn on. So we'll do let instruct command verb command string equals components 0. Let x1 equals components 1. Let y1 equals components 2. Actually, these are going to be integers, so I'm going to parse it as an integer. Int let x2 equals int components 3. Let y2 equals int components 4. Okay, and then regex parse. Okay, so then I want this command. I'm going to give it a string as a raw value. And this is going to be turned on. This will make it nice and easy to parse it into, to pull it into this enum. Turn off equals toggle. Because now we have this component string. So we're going to do command string let command equals command command. Oh, actually, let's do this. I don't need to do that. Command raw value. What's wrong here? Invalid escape sequence and literal. Oh, shoot. Okay, all of these have to have double backslashes. String must be unwrapped. Okay. Command was never used. Okay. Self.start coordinate equals grid coordinate, and that is going to be xy. It's going to be x1, y1. Self.end coordinate equals grid coordinate x2, y2. Okay, and then self.command equals command. Okay, good. So now we have our instructions. So now that should, if we go to input.lines.map transform instruction.init. So what that should do is it'll take all of our lines and convert them into instructions, which we can then work with. Oh, these must be unwrapped. All right, I'm gonna use the unsafely unwrap operator. If it it's just a puzzle. If it crashes, and that tells me there's something wrong with my code, because the input is pretty normalized. Oh, that was from yesterday. Here, the input is pretty normalized, so I'm not worried about how that's gonna look. Okay. Let instructions equals, okay, description descriptor. Okay. Oops. It's unusual. So it's possible that the input will be parsed differently in the next part, but that's unusual. So I'm going to go ahead and let this be. So we have our lights, we have our light board. So this might just be, let's see, if we do instructions, let instructions, no, we do let LB equals light board, and then we do LB dot, and then instructions dot for each LB dot process, right? That should be allowed. Okay, and then now we just need to count the lights. Var illuminated lights. Let's do all lights. Now illuminated lights. We should return the illuminated coordinates, right? Var lit coordinates, and that is going to be a set of grid coordinates. And the way that works is we're going to do lights dot keys dot filter is included in chord, and we're going to say lights chord dot is on. We're going to default it to false, because this could potentially return null. In my algorithm, it wouldn't return null because the puzzle input is pretty, normalized. It wouldn't go outside of the bounds, but if, the input did go out of the bounds, we're going to return false. Okay, so this should return a set of grid coordinates, and we're going to say return lb.lit coordinates.count. But it has to be a string, so we're going to go like this. Okay, good. So now we're going to do our test cases. So in this case, I'm just going to test case. I'm going to do each input one at a time. Okay, expected output, that should be 1 million. Okay, because it's returning on literally every single light. Okay, text. Okay, toggle. Okay, expected output, put the close parenthesis, expected output is going to be 1000, because they all start off, and it's going to toggle the entire top row. Expected output is going to be turn off the middle 4 lights. Okay, so that's going to be 4. Okay, and then it doesn't tell me how to process the entire list. So here we go. We're going to give this a shot. I need to copy my puzzle input, see if the test cases pass. Copy. I'll be surprised if this works the first time. Number 6. Okay, what's going on? Compiling to return type set grid coordinates. Okay, lights filter. Oh, I see. Set. I need to wrap it as a set because this filter command returns an array, not a set. Why is it taking so long? It shouldn't take that long. Ooh, that's not good. Expected 4, actual 0. How did that happen? Turn off. Oh, okay. I have an idea. So we're going to do 2 instructions. So if I do, this is going to be 1000 minus 4, which is going to be 999,996. Let's try it again. I'm surprised it takes so long to run. I would have thought it would rip through these pretty quick, but I guess a million is a lot of numbers to toggle lights on and off. Okay, that was 3 test cases. That's it. Should be working. There we go. Solving A. Not sure why that long. Not sure what that long pause was. That was odd. Okay, solving A. It occurs to me that each one of those is 1 instruction. So if it has to go through a whole bunch of instructions, this might take a while. Let's see what happens. After this is probably going to be like, oh, also now render the output so you can read the message that is in the lights. That happens a lot. Okay, wow. 400,410. Let's see if that's the answer. Submit. Woo! Got it. All right, continue to part 2. You just finished implementing your winning light pattern when you realize mistranslated messages from ancient Nordic Elvish. The light grid you bought actually has individual brightness controls, each light that can have a brightness of 0 or more. The lights all start at 0. The phrase turn on actually means that you should increase the brightness of the light by 1. The phrase turn off means actually that you should decrease the brightness of those lights by 1 to a minimum of 0. The phrase toggle actually means that you should increase the brightness of those lights by 2. Okay, what is the total brightness of all the lights combined after following Santa's instructions? Okay, so this is actually kind of interesting. So we're going to take our total brightness of all the lights. Okay, so instead of process, I'm going to have a function here. I'm going to call it function process 2 instruction. And that is because I could probably even subclass. You know what? I'm going to subclass lightboard. And I'm going to override process. That's what I'm going to do. Lightboard 2 and extends lightboard. And I'm going to override func process instruction. And so we're going to start by, getting all the affected lights. And then for each affected light, switch instruction Oh, shoot. Ooh. Increase, var brightness. Brightness. Okay, so the light needs see, so I was smart for not making this a Boolean, because now this is no longer just a single true-false state. It's going to have a brightness. So turn on brightness is, oops, that's brightness. Two S's. Brightness plus, oops, plus equals 1. Wait, holy shit, I don't even need this subclass. Everything else is the same. I just need to affect how the lights are interpreted. Brightness plus minus equals 1. Oops, minus equals 1. And then at a minimum of 0. If brightness is less than 0, brightness equals 0. And then toggle. What was it? For these toggle actually means you should increase the brightness of those lights by 2. Okay, so we're going to do we're going to do brightness plus equals 2. Wow, okay, this is going to be really easy. So now all I have to do is get the var total brightness, and that is going to be an integer. Actually, this should be, yeah, let's just do an integer. And that is going to be, we're going to go through all the lights. Lights, L-I-G-H-T, lights dot values dot map. Oh, this is gonna be beautiful. Map brightness dot sum. Is there a sum? No, we're gonna do a reduce. 0 plus. Okay, this just works as a sum. Build succeeded. Perfect. So now for number 2, all I have to do is instead of lit coordinate stat count, I just have to return lb.brightness. Total brightness. Yeah. Oop, these are test cases. I pasted this in the wrong place. There we go. Instructions, light board for each process, total brightness. Okay, and now I'm just going to have this return unsolved because I don't want to have to wait for A to run again. I'm going to get a warning that this is, I'm going to get a warning that this is, yeah, unused. Okay, so let's get our test cases. Turn on 00 through 00 would increase total brightness by 1. Okay. You know what? It's probably the regex parsing is what the issue is. Well, no, because you only need to do that once, and then we have the instructions. So, and you only have to do it. Yeah, never mind. So there's no way the regex parsing is the issue. Okay, and then what was the other one? Toggle, increase brightness by 2000. Okay. Expected output. I think actually that's 2 million because we're increasing the entire grid by brightness of 2. Okay, so we are going to try that. Let's make sure our uh-oh. Oh. Ooh, okay. Expected 0, actual 1. Did I misenter this? Oh, yes, I did. Okay, so we're going to try again. That was my bad. I inputted the expected output incorrectly. Yep, test cases A, we're not interested. Pass. Takes too long to run. All right, here we go. Test cases pass. Let's see it rip through these instructions now. I should look into my runner here because there's this weird pause after the test case is complete. I have a feeling I'm inadvertently running the test cases again silently to like as a check before I actually solve the puzzle. I should try to optimize that, because some of these puzzles are going to take quite a bit of time to run. So like this one, it might take a couple seconds, but there are going to be puzzles in the future that take, a couple minutes to process, because it's just huge. The input is huge. Okay, here we go. What is that? 1,500,000 something thousand? 1,534,000. No, 15,343,601. Submit. Oh, yes. That's the right answer. Beautiful. That was actually a really easy part too, and it's because I modeled the light as a class instead of as a plain old Boolean. It was tempting to model as a Boolean because it only had like turn on, turn off, and toggle, which you can do all of that stuff with just a Boolean by itself. By wrapping it in a class, we had the ability to extend it and offer brightness instead of the true false is on. And that actually paid off big time. Okay, so we'll go back to our advent calendar. All right, we are all done with day 6. I will see you tomorrow for day 7.